Could you provide any feedback or critique on my attempt to explain lineage selection to myself? The lineage selection scenario. Suppose an individual organism has adaptive and advantageous features and behaviors which help a related organism to survive up to the point of reproduction. Then these features will make it more likely that the overlapping subset of genes the organisms have in common gets into the future. If the features or behaviors are themselves coded in the subset of related genes which get passed on, these features will be preserved and hence naturally selected. Supplementary parts if there's time. Unlike the standard survival of the fittest scenario, even if the individual organism dies before it can reproduce, then provided it has still helped a related organism to survive and reproduce, their common subset of genes, and hence some of the individual's own features and behaviors, will still make it into the future. Lineage selection operates at all different levels in order of how much of the organism's own features are likely passed on, helping the individual itself, the individual's offspring, the individual's siblings, the extended family group, social group, tribe, species, etc. Lineage selection readily explains features and behaviors which are conundrums or paradoxes in the standard model, such as altruism and self-sacrifice, and interlineage competition, such as tribalism and genocide.
Right. All right. So you're definitely in the right neighborhood. I'd make a few observations, which is what you've described is pretty well covered by kin selection. The problem is that we, for no reason I can find, draw a limit on kin selection, right? Where we see kin selection stopping more or less at named kin, right? And then we treat everybody else as sort of other. I don't know why we do that.
By named, you mean relationships for which the language has a name, like cousin.
Yeah. Right. Yeah. Third cousin. Sure.
Sure.
But the point is the degree to which an individual is related to another individual tails off to baseline pretty quick, right? And so that's probably the reason that we don't see kin selection extending out. But the point is, well, wow, I don't know how we're going to do this in
it's tough.
Lay terminology without a chalkboard and things. But here's the problem. All of the bodies in this quadrant of evolutionary biology are buried under the term heritable. Okay. Now, heritability was understood by Darwin. He understood that creatures get characteristics from their parents, right? That's obvious. He did not understand genes. So when he invoked the concept of inheritance, he was not talking about genes. But when genes were discovered, right, there was a battle. Where is the information that's being selected housed? Is it in protein, which made a lot more sense, frankly? Is it in DNA, which made a lot less sense because it's only a 4-letter alphabet? Which of these things is it? When DNA won that battle, and the way it overcame, hey, it's only 4 letters, is you take 3 of them at a time and you get 64 combinations, right? So DNA wins out. It is the place that information is stored and therefore selected. And the world shouts Eureka. And this is such a powerful idea. And it's so true, except for one little asterisk, that we accepted this as the Darwinian mechanism, rather than actually, that's certainly a Darwinian mechanism, but there can be an arbitrarily large number of these things.
Yes.
So we should not stop looking for other ways that things are inherited. And the problem is
classic reductionism, frankly.
That we define.
Eureka, we found it, as opposed to Eureka, we found something.
We found one.
It's explanatory. We found one.
Right. Mm-hmm. So anyway, heritability got hard coded as genetic transmission, and what's more, it got hard coded as variance. So to the extent that a gene is so awesome that every single individual ends up with it, because no individual without it could possibly compete, as it goes to fixation, its heritability drops to 0. Right? You'd think it would go to 1 because everybody gets it, but it goes to 0 because there's no variance. Right?
Bipedality in humans is not heritable because we're all bipedal.
Right. Now, here's the problem, though. Okay. Now, let's say we do that analysis and we say, okay, we've got this fancy new definition of heritable and it's super powerful and we can do all kinds of cool things with it. Is this gene, let's say we found some gene, we don't know what it does. Okay. Or does it produce a heritable trait? Right. Okay. Maybe it does. Maybe there's some variance, right? Or maybe it's not heritable because it's fully fixed in the population, right? And then some person who doesn't look like the population in question lands on the shore and we genetically test them and it turns out they don't have the gene at all. So if it was fixed in one population
the allele,
and absent in the other, the allele, if it was absent in the other, then is it heritable or not? It depends over which population you're asking the question. All right. So take all of that and say, there's some problem with the definition of heritable, which is we think we know exactly what we mean when we say it, but really we have to specify over what entity we are asking the question before we have any idea whether we know what we're talking about. Which means that if we say, well, selection acts on heritable traits, right, and a bunch of traits are fixed, therefore selection isn't acting on them, but then we discover there's a population in which the trait isn't there, and so then selection has acted on it, we don't know how to talk about the question. And my point is, look, everything you said about kin selection is still true when you get to populations, right? All of the reasons that you might act in a certain way that is hard to understand from the point of view of your passing on your genes directly, but that makes sense because you actually aided your children in passing on your genes, or your grandchildren, or your cousins. All that stuff makes sense if the idea is, here's a patch of territory. If my population remains on this patch of territory 1,000 years from now, I have succeeded. If that other population, which is threatening us, has taken this and none of my descendants are here, then that gene has blinked out, right? So from the gene's perspective, it might make a lot of sense to behave in a way that makes no sense from the individual or even the normal classic kin selection perspective. So the answer to your question, I think, is you will see why lineage selection is a power tool when you take the idea that lineage selection is a fractal and you work backwards from it and you realize how different that makes each analysis.
And the power of the fractal here is, in part, it's born of, and correct me if I'm wrong here, but I think some of the reason that you begun to think actively in this space was, that there's broadly, so there's a lot of different ways to categorize evolutionary biologists. Broadly speaking, one of the most common ways is sort of microevolution, is looking at within population dynamics where selection and mutation and genetic drift and gene flow are paramount. And then macroevolution, which is origin of species stuff, level of, clades, what are each other's closest living relatives within, clades as a, rodents and rabbits versus, two people living in the same town. Very often there's sort of a hand-waving black box, there must be some additional process going on. And in part, what you are describing and what we've written about and what you specifically have written about in your dissertation as well, I believe it's in there, is why would you invoke a whole new kind of evolutionary process which you haven't even managed to describe when you could do your explaining with tools that we already have? With mechanisms that we already have.
Right. In fact, there's
the fractals. If it works here, why wouldn't it work here? And maybe we're just not looking at it the correct way. Yeah,
it's a burden of proof issue, which is prove to me some new process does this when some old process clearly has the power to. Right. Why are you adding epicycles when we don't need them? Because what we've already got on the table explains this perfectly well. So another way to think about this. So first of all, why did I start thinking about this? Because there's lots of stuff, really important, big, expensive stuff that is obviously the product of adaptation in one way or another that can't be explained by individual selection or kin selection in any standard terms. A lot of us have noticed this. This is the thing that keeps driving people to reinvent group selection, right? You've got this giant church that took 300 years to build. Somebody set it in motion. Why did they do that? Is that kin selection? It's hard to see how standard kin selection does it, right? On the other hand, if the whole town is the thing that is benefiting from it, then it does make sense. So, the town isn't kin, it's a group. Well, it's a group, but that's not all it is. It's also a lineage, right? Is it exactly one lineage? Not necessarily, but is the lineage selection that exists in the town enough to drive this, right? Is the remote church and all of its offshoots, that is to say, the remote church represents a lineage. So the point is you've got all the power you need, you're just not leveraging it and invoking new processes. Group selection is basically in the same way that lineage selection is an extension of kin selection. Group selection is an extension of reciprocal altruism. And the idea is if we all behave altruistically to each other, we come out ahead, which is true, but it's game theoretically unstable, which is why we shouldn't and don't see it. So anyway, somewhere in there, I think you should be able to recover the answer to your question. But, what I mean when I say lineage selection is a fractal is that if you look at a complex biological scenario, you will note that there are many lineages present. And which one will see the scenario in what way is the question. What is the dominant phenomenon here, right? Is my fitness as an individual the driving factor in how much success I can take out of the situation? Or is the chance that my population will be here 500 or 1,000 years from now actually the key to whether or not I've succeeded or failed? Depending upon which of those questions is actually the more powerful one, that's the place that you will see selection favor.
You want to just turn on my screen for a second?
Sure. You mean put your screen up?
Yeah, let them see my screen.
Right.
Yes, indeed.
Okay.
I really like this mug too, incidentally.
That mug?
Yes.
Yes.
They
like your mug.
They like my mug, yeah.
That's interesting. That is a thing now. That didn't used to be a thing. People remotely liking your mug.
Yes. Well, anyway, one thing you just said. So what I'm going to have Bret put up here is a slide from a lecture I used to give in my very first lecture in my sometimes year-long vertebrate evolution program, which is a visual that was created by Arnold Kluge, who was my graduate advisor and one of the greatest living phylogenetic systematists, in which he would describe on A here, basically each of these vertical lines are individual lifespans. And then the horizontal lines in A are basically reproductive events. Two people come together and they do or they do not make kids. And then that sort of scales up, fractal style-ish, scale up in terms of time, not so much space, but yes, space too to some degree. And you end up with these sort of interweaving and still sometimes reticulate versions of how evolution works. And then once you get to actual phylogenetic trees, at least with some distance, you don't get reticulation. You don't get, a donkey and a bird coming back together and making a hybrid. They're too far apart. So you get bifurcating pattern of cladogenesis, but you never get them coming back together. But what prompted me to want to put this up was what you said about God, excuse me, this is now gonna happen a lot as we talk. You said something specifically about, are they distinct lineages in the town, right? Well, given that we are sexually reproducing, and we have been consistently for at least 500 million years, maybe as much as 2 billion, but given that we are sexually reproducing, what does it even mean to say, are they one lineage? Because with every reproductive event, you are bringing together two lineages and you are making another one. Right. Well, and so, there is all this reticulation at sort of the fine-grained individual lifespan level. And even at at stage B, which doesn't have a name in evolutionary biology. And this of Kluge's visual, which I loved enough to continue teaching with up until the very last quarter that I taught at Evergreen. A is individual lifespans. We can all sort of grok that once it's explained to us. C is a phylogenetic tree, which takes a little bit of time to walk through. But B doesn't even have a name. But it points, in evolutionary biology, I've never heard anyone call it anything, invoke it, except by looking at this visual. And for me, some of its power is there's a point at which reticulation no longer happens. Plants is different, but in animals. And that, in part, reveals that sexual reproduction does change, to some degree, how it is that we talk about lineage and what its implications are.
Yes. That's true. There is no barrier. No. There is viscosity below the species level, and there is no absolute barrier at the species level.
What do you mean by viscosity?
I mean, the way one's religious parents look askance at you if you fall for the wrong girl, right? That is a viscosity that prevents a certain amount of reticulation and fails to prevent a whole lot of other reticulations. So the point is, how likely are two lineages? Cultural
constraints on incest is viscosity.
No. Not incest. The one immigrant population not wanting its offspring to partner with members of the dominant population or another immigrant population, right?
Okay. So I guess I'm not sure how you're using viscosity. What you're talking about is sort of keeping outbreeding avoidance.
Yeah, by whatever mechanism.
Yeah.
So that thing has some impact on lineages. Every time a lineage touches another lineage, is it immediately just one lineage? No. And in fact, the beauty of the concept of lineage is that it is perfectly precise in what a lineage is. A lineage is an individual and all of its descendants, right? So the point is we can describe every lineage in a town, or every lineage that begins in a town, and they all simultaneously exist. However, the thing to notice, if you take standard kin selection, and you think, I get it. My genes want me to leave as many copies of me as possible, right? That's my job, is to produce as many offspring by whatever skullduggery and lying and committing and all the stuff that I'm supposed to do, right? Let's say you wildly outstrip expectations and you leave 10 offspring, which is 5 times what you would be expected to, right? You have had essentially no impact on the likelihood that your genes will be at a given level extinct, doubled 1,000 years later. So our obsession with this, right, and the fact that we are driven to behave as if what matters is our individual reproduction, is an accident of evolutionary history. Far more likely that what dictates whether or not your genes are well represented in the future is how you behave at the level of your town, your nation, these things, right? Your nation is in a position, and in fact, a good nation every day of the year staves off all of those who would like to displace you and take your stuff. So the point is, mess with the stuff at your peril, right? But if you understand that you are part of a population and that population has an evolutionary meaning and its chances of getting into the future are dictated by large patterns, not small ones, then you will realize that you are viewing through distorted eyes, and you will understand why so much of history is governed by people shouting at each other over ideology and over nation. It's not about the content of the ideology or the structure of the nation. It's about, will my population be here 1,000 years from now?
3 things. We should move on. I need my screen back to do so. And while I'm getting my screen back, which is only going to take me like 2 seconds once you've done that, can you give a very brief definition of lineage?
Yeah, I just did. A lineage is an individual and all of its descendants. And so an individual and all of its descendants, at the moment, Heather and our 2 children are a lineage. I and the same 2 children are also presumably a lineage, right, Heather?
Yeah.
Heather and I and our 2 children are not, because we have come together to produce these 2 children. So that's an interesting quirk, not very important that you understand it. The really important thing to understand, though, is that there is some individual animal whose fossil essentially certainly has not been preserved. It will never be in a museum. We will never know everything about it. But there's some individual animal that was the ancestor from whom all living mammals are descended, right? So that is also a lineage, right? Mammalia is a lineage that defines an ancestor we cannot know, right? So all of the things in between are lineages. So too is vertebrata a lineage, right? So when I say fractal, the point is this is an item so powerful that it works at all these scales. And when you get to the species level where all sorts of things are supposed to change, you realize only some of them do, right? The fact that species are embedded in larger lineages raises a question about strategies that allow species to get their genes into the future by diversifying their portfolio into multiple species. So anyway, biology is interesting. That's how I see it.
Okay. The second question is also about lineage selection, but let's make it brief because we've already been at it for a while.
Okay.
With lineage selection, why are inherited crimes and injustices wrong? It feels morally wrong to have the sins of the father visited upon the son. But if it's a battle of lineages, shouldn't we impose a cost on a cheating lineage?
Somebody is paying attention. Who is that?
Christopher.
Well, here's the problem. You're right? It makes perfect sense.
Hey guys, that was a clip from our monthly private Q&A that you can get access to at my Heather Hying's Patreon. And you can also get access there to all of the past paid subscriber content. So please consider joining us there.
Did you mention that these private Q&As are the key to living a better life and living to tell the tale?
I forgot to do that. These private Q&As are in fact the key to living a better life and what?
Living to tell the tale.
Living to tell the tale. Go ahead, live to tell the tale. Join us there.
See ya.